Okay, today we are going to learn how to create visualizations from data using R, and specifically we are going to focus on the library called ggplot. ggplot is one of the libraries within the larger tidyverse ecosystem. So dplyr, ggplot, and many more libraries are together, like they're friends of each other, and they are all together called the tidyverse. So it's written like this. So we will directly call this library. And again, if you're getting an error when you call this, and you see like some of the library names are listed here that have been called, we can install it with install.packages, quotes, and within the quotes tidyverse. So if you were to run this line, right, so you can you will basically do the installation, and after you do the installation, comment it out so that you don't repeat the same thing when you open the file next time, because we don't need to reinstall back and over and over again. So we are going to just call the library tidyverse as I did here. Okay, so in this exercise we are going to read in a dataset a CSV file called AutoMPG. The AutoMPG is already in the same location of my file, so I can directly call it, and I'm using the underscore version here. So this read underscore CSV is the tidyverse version of read.csv. So read.csv, this is the base R version. They will pretty much do the same thing. I will just I just prefer to use read underscore CSV, which is I think either under read R maybe library. I'm not sure which library it is. Let me quickly check. Yes, it's under the read R library, as you can see. Again, these are part of the tidyverse. It will just do a few more things that read.csv wouldn't do. So that it will make the data a bit more easier to work with right from the start. So that's why I will use read underscore CSV. Let's save this into a data frame called df. All right, let's check how df looks like. So there's 398 columns and 398 rows and 9 columns. This is how the data looks like. Let's check the structure of the data. All right, we have all numeric columns here. There's the car name as well at the end. This origin though is something that we will be careful on, because although it says numeric here, actually origin represents something else. Origin means where did the car, where was it manufactured? There's 3 locations here. One of them is USA, one of them is Europe, and one of them is Japan. So although it might be numeric here in the data, it actually is a categorical variable. Okay, so that's something we need to be aware of. So just like str, there is another function actually in dplyr, which is called glimpse. So it kind of does the same thing. Yeah, but just a little different. So it shows more values at the initial rows in the data set, and it shows what type of a column it is. So this is a glimpse basically without kind of directly taking a look like this onto the data frame. You kind of just have a quick look, let's say. Maybe that would define it better. But at the end, they pretty much do the same thing, both str and glimpse, so you can use both. Okay, let's start with a scatter plot. Scatter plots are useful when you have 2 numeric columns, and you want to see the relation between them. So the base R of that, so let's start with that one, is plot function. And then I will give the first input. Let's say I want to see like this horsepower, and the relation between horsepower and miles per gallon of a vehicle. So horsepower, miles per gallon. So this goes to the x-axis, and the second one goes to the y-axis. So miles per gallon versus horsepower. So you see there is kind of this relation. So when the miles per gallon, or when the horsepower increases, right, to the right, you can see that the miles per gallon actually decreases, and that makes sense. So more powerful vehicles will consume more gas, and that's what you can see clearly from this figure as well. Now, this is the base R way of doing stuff, so let's try to make use of this new library. So I will make use of the ggplot library. Okay. So in ggplot, let's build this, step by step. So if I just run this, ggplot open close parentheses, nothing. You can see an empty canvas. So that's the first step. Right. So now let's add more thing to this. So the first input for this should be the data frame name, which is df in our case. If I run this, I will still have nothing. I will just have an empty canvas. But right now, ggplot knows that it's going to make use of this data set. In the next, I will provide the aesthetics. So what aesthetics means is that things like you want to represent in your figure. So what do I want to represent? I want the x-axis to be my horsepower. Horsepower. If I run this, okay, now it puts horsepower onto the x-axis. There is still nothing on y because we didn't provide it yet. And on the y-axis, I want to see mpg. Okay, I have horsepower on x and miles per gallon on y. It also did take a look at your dataset, and these values come basically from the minimum and maximum values present in those columns. So it didn't put anything in the figure yet because we just said, okay, I want x-axis to be horsepower. I want y-axis to be mpg, and I didn't tell anything else. So it doesn't know what kind of a plot it's going to create. Is it going to create a scatter plot, a box plot, a histogram? What is it going to do? It doesn't know anything yet because we didn't tell it to do anything yet. So that's the next step. Here I will put a plus. There's a plus sign outside of these parentheses. And then I will say I want to create a scatter plot, and scatter plot in R is geopoint. Geopoint means basically make use of the dots. So now you can see all the dots appearing in the data. MPG versus horsepower. I'm not sure what it is complaining about. Oh, okay, that's gone. Okay, that was I don't know what that was there. So yeah, so you can see the same figure, same shape, but quickly you can see that the ggplot version looks actually, again, without any modifications, right? This is using the kind of the very straightforward, no changes default version of ggplot. It still looks much better than the base R version of the plot, as you can see, right? So the axis looks much better, and the dots and overall the plot looks much nicer to me. All right. So that's the scatter plot right there. Let's create another scatter plot. Go here. Let's say I want to create. Again, as input, the first thing is the data, and then I want to create the scatter plot of cylinders on the x-axis, and on the y-axis again I want to see mpg. So I need to write x equal to cylinders here, and I will put geopoint to create a scatter plot. Let's see how this looks like. So you can see cylinders are integer values, right? And they are very discrete. So 3 cylinder vehicles, 4, 5, 6. There's nothing on 7. So there's no 7 cylinder vehicle, and then there's 8. And you see how the MPG is varying, right? Because cylinders is integer, they are basically, all the points will basically stay on that straight vertical line there. That's why it looks like this. If you have data like this and you still want to see, so generally, okay, first of all, scatter plots are generally very useful when you have numeric versus numeric. So this cylinder is not exactly a numeric value, right? It's more of a discrete nature. And actually you can even treat this cylinders of categorical type as well if you wanted to. Again, that's a bit up to you on that. So it's not exactly numeric. That's why you see this kind of behavior. But that's still okay. There's no problem in that. If you want to just, rather than putting every point on top of each other like this, you might want to add some jitter there. So basically what that means is that it will add some random values to these data points so that there's some variation here. Some of them will go to the left, some of them will go to the right, right? Kind of a random noise will be added to those points. This width value shows how much of a randomness you want to create in those points. If I run this one now, you can see a bit of random values are being added to those points, so that some of them will move left because it's minus random noise, and plus random noise will create them to move, will make them move to the right. So now you see a bit more variation here. So here everything was kind of just straight line. You wouldn't know where there is more points or less points. But now you can see, okay, there's more points, for example, here in this area compared to this top here. Or this one is easier to see. So there's more points around here compared to the points around here. That's geom jitter. Behaves similarly to geom point. It just adds random noise to the data. Let's continue. What I want to do is actually I want to make the ggplot even nicer, the scatter plot even nicer with coloring. So I will take this code right here, not this one, but this one. This plot right here, right? So miles per gallon versus horsepower, and I want to add colors to this. Okay. Well, there's two things, by the way. So when I say color, I mean, if I want to, rather than black points, if I want to see red points, here I can add color parameter, color argument inside the geom point. I can say color is equal to red. And a neat thing about the new version of R in R Studio is that you can see that once I wrote red here, this parameter turned with a background into a red color. So you can directly see how that color will look like. I mean, that's something neat, I think. For example, there's green. If I write green, you see that green color looks like that. If you run it, you'll see you will get green points. There's different types of green. There was something called forest green, if I remember correctly. Yeah, so this is a bit darker green. You can see directly how it looks like there. If I run this one now, see this green I think is prettier than the other green there. So this is one way of coloring the dots. So again, this just makes it very, instead of black points, you will see different colors there. But actually the way I wanted to color this is a bit different. I want to use color within this aesthetics area, because I want to do this. I will say color is equal to, and then I want to point the data points. I want to color the data points based on the values of a column that I'm interested in, right? For example, I think cylinders will be a good candidate here. I will color each of the data point based on the cylinder of that vehicle, right? So each data point is a vehicle, and they will be colored based on the number of cylinders of that vehicle. So see, when I run this, so the darker colors you can see from this legend here is smaller cylinders, and the lighter colors is the larger cylinder vehicles. So you see the larger cylinder vehicles are more around here. They are colored with this light blue, so they have either 6 or close to 8 cylinders here. And it makes sense, right? So the larger number of cylinders generally means the larger cars, bigger cars with more horsepower. And you see that from this figure very clearly. And they will also have a smaller MPG, and you see that very well here as well. The other way, when we look here, this area of the figure, top left corner, you will see you're seeing dark colors because the number of cylinders is much smaller here. So the MPG is much higher for these vehicles because they are smaller vehicles, and their horsepower is also smaller, right? So this coloring makes much more sense now. So another thing I wanted to show here is this. So as I said, cylinders is being treated as numeric value here. That's why you see this legend in this way. If I wanted, I can add some flavor to this. I can actually change cylinders into a factor type, and factor type in R means categorical type. Rather than treating each one of them numeric and then coloring them in a sequential coloring like this, it will give them distinct colors if I do that. And I can do that right here in this code within color. So I can say color is equal to S factor. So S factor will convert this numeric values into a factor type. Again, factor means categorical in R. Run that. You see now they have each discrete colors, right? So you can see clearly, for example, 8-cylinder vehicles is this purple color here, and this light brownish greenish color is all 4-cylinder vehicles. right? You can see them all here. And in the middle, you have blue color, which is 6-cylinder vehicles. And in the data set, there's only very few 3 and 5-cylinder vehicles. These are very, randomly. I mean, very rarely here. You can see them around here. So all these areas, actually, almost all of them is 8-cylinder vehicles. And almost all of the vehicles here in the top left is 4-cylinder vehicles. All right. So this is the effect of what type of a variable you use for coloring and how that coloring will change based on that. You see discrete colors here, no sequentiality. But here, if you use numeric value for coloring, you will see this behavior where there's a gradual change from one color to another. Okay, so that's it for ggplot.